to do the upside down cup experiment. Firstly, we are going to fill the cup up with water. Then we're going to put a cupboard on top of the cup. Placing our hand on the cupboard, we're going to slowly turn the cup upside down. Then, very slowly and carefully, we're going to release our hand from the cupboard. As you can see, the lid doesn't fall off and the water doesn't spill out. This is because the atmospheric pressure all around us is pushing the cupboard upwards is greater than the water pressure inside the cup.
Assalamualaikum. My name is Muhammad Norshafeeq, and I will continue with the next part, which is calculation that prove the reason why the water does not spill out. First, calculate the pressure by the water at the bottom of the glass using the formula rho GH, where rho is density of water is equal to 1000 kilogram per meter cube, and G is gravity is equal to 9.81 meter per second square, and H is height of glass is equal to 12.5 centimeter or 0.125 meter. Next, calculate pressure exerted by the bottom is equal to negative rho GH or rho GH in upward direction. To calculate, you substitute the value into the formula which is 1000 times 9.81 times 0.125. Then calculate, and we will get 12.2625 times 10 the power of 3 Pascal outward direction. Next, the glass is turned upside down, and there are two pressure acting in this condition, which is atmospheric pressure is equal to 101.325 times 10 the power of 3 Pascal, and the next pressure is the pressure exerted by the bottom of the glass, which is equal to 12.2625 times 10 the power of 3 Pascal in downward direction. As my friend Izzat said in the video before, we can conclude the reason why the water does not spill out are because the pressure exerted by air upward, which is the atmospheric pressure, is more than the pressure exerted by the water. That's all from me. Thank you.
Okay, then we go to the next question, which is question B. The real life example of a product process of fluid mechanics, which is we choose hydraulic jack and principles law. Hydraulic jacks, which come under the category of a closed container, follow the principle of Pascal's law. Hydraulic jack. The hydraulic jack consists of two cylinders, a larger and a smaller one. These two cylinders are connected. When its handle is pressed down, a valve closes and a small piston forces the fluid through another valve to a larger cylinder, which then produces a large force to be transmitted to the load. When force is applied, the pressure is exerted throughout the volume and surface of the cylinder. Then, the handle is moved up and down repeatedly until the load is sufficiently lifted up by the hydraulic fluid flowing buffer tank to the small cylinder. Okay, next is a Pascal's law. Pascal's law in fluid, gas or liquid mechanics statement that in a fluid at rest in a closed container, a pressure change in one part is transmitted without loss to every portion of the fluid and to the walls of the container. When a fluid is at rest, the same amount of pressure is delivered to all places at the same height. Pressure isn't a vector quantity and so can be assigned to any direction. If we consider a fluid as a horizontal bar with a uniform cross-section that is in equilibrium, we can see that there will be an equal and balanced force exerted at both ends. If the horizontal bar is subjected to an unequal forces, the liquid will be subjected to some net force. However, if we consider an unequal force applied on the horizontal bar, the liquid will experience some net force and flow. As a result, it is correct to state that because the liquid does not flow, it is under equal pressure at all points.